This video is just a reminder about area and volume using trig functions. So remember, you can use definite integrals to find area and volume. When the area is bounded by the curve y equals f at x, the x-axis, and the lines x equals a and x equals b, the volume of the solid form is this. So the integral from a to b times pi y squared, right? This represents the radius of that solid that is being rotated. This is in your formula booklet if you were using it on the exam, so you don't need to memorize that formula. In the event that you have the area bounded by two curves, you would just have to remember to do, you'd have the area from a to b, y2 minus y1 dx, where y2, this would be the top curve, and then this would be the bottom curve here. Okay, same holds true for doing the volume, but that's a little bit more complicated than we need to do. Okay, so let's look at our first example. So we're going to consider f at x equals e to the minus 3x sine x in between minus 1/2 and 3. So the first thing that we're asked to do is show that f prime at x equals e to the minus 3x times cos x minus 3 sine x. Okay, so we're going to take our derivative using the product rule. We have one function multiplied by another function here. So we've got our f and our g. So when we take our derivative, we've got f prime at x is going to be g f at x, sine x. So g times f prime, and our f prime here would be minus 3 e to the minus 3x plus f times g prime, which in this case is going to be cos x. Now remember, we're trying to get to this expression right here, so that tells me that I'm going to factor out e to the minus 3x, and then we're going to end up with cos x minus 3 sine x. In an exam situation, you would get the marks for this step, not for this one, because the answer is already given to you. Nice way to know if you're correct. Even if you can't do part A, a show that question gives you the answer so that you can still do part B. Let's try that. Now we're going to find the equation of the tangent to the curve at the point P, pi over 2 e to the minus 3 pi over 2. It looks like it's all in the exponent. Let's change that. So we've got P pi over 2 e to the minus 3 pi over 2. Okay. So first thing that we're going to do is we're going to sub in our x value, pi over 2, to f prime at x to get the value of the slope. Value of our slope. And then from there we can do our equation. So we've got f prime at pi over 2 using our f prime factored form from part A. And then we've got cos pi over 2 minus 3 sine pi over 2. This is going to simplify for us a little bit. We're going to get e to the minus 3 pi over 2, and then times minus 3, because sine pi over 2 is equal to 1. And so we get our final answer for the slope as minus 3 e to the minus 3 pi over 2. Then this allows us to state our equation. You can use whichever form you want. The easiest one is the y minus y1, and then m times x minus x1s. That would be the easiest. Okay. The last thing that we're going to do is find the area between the curve and the x-axis from x equals 0 to x equals 1. So our area, we're going to start with our formula. So the integral from a to b of y, our function, dx. So we've got our a, our b, and then our curve, that's our f at x that we started with. So our e to the minus 3x sine x from part A. So you've got the area is the integral from 0 to 1, e to the minus 3x sine x dx. This would be a GDC integral, so you can use your graphing calculator. And what you should get is that the area is approximately 0.0847 units squared in between that curve and the x-axis. The questions that you should try to go along with these applications are in 14G.